Hello there, this is Mr. Big Hair Roche, and welcome to Mr. Roche's flip class. Low budget, low tech, no frills, no thrills, Math 10 videos. Today's lesson is going to be on relations and functions. This is part 4, it corresponds to lesson 4 in our workbooks. And today's lesson is on domain and range. As usual, I have Wilson, who's attending today. Whoop! And he's going to find out how to do the same stuff and operate the camera. Wilson, go sit down over there. I can't let go of this today. Not for a bit. Okay, so in this lesson we're going to define what range and domain means. We're going to be reviewing number sets, because it'll be used throughout this lesson. We'll be reviewing graphing inequalities from Math 9. We'll be talking about the set builder notation. And also I'll introduce the interval notation to you, because you might run across it somewhere along the line. So here we go. First of all, the domain is all the possible values of the independent variable. Okay? Usually that's x if we're just talking about x or y, but of course it could be any other independent variable. The range, on the other hand, are all the possible values of the dependent variable. Oftentimes it's y. Okay, so if we're dealing with x and y, this is the x values, this is the y values. As far as the number sets, the natural numbers, remember, are you counting numbers? 1, 2, 3, 4, 5, and so on. And that's denoted with big N. Whole numbers are 0, 1, 2, 3, 4, 5, forever. And that is a big W. Integers are positive and negative whole numbers. So you negative infinity to positive infinity. That's a capital I. The rationals are anything that could be written as a ratio or as a fraction. So that includes all of these, as well as decimals and fractions. And those are going to be my... Oh, I almost made a mistake. Q for rationals. And the irrationals are those things that cannot be written as a terminating or repeating decimal. Things like pi, the square root of any number, the cube root of any number, unless they be a perfect square, perfect cube, etc. That's a Q with a line over it, okay? Which means the complement of Q or the opposite of Q. And the reals is like an italicized R. Okay? Okay, first let's look at graphing inequalities from grade 9. We learned that the inequalities are greater than, greater than, equal to, less than, equal to, or not equal to. In this particular question, let's say we were to graph the inequality and it looked like this. Okay? This means it could be anything greater than 5. The hollow dot indicates it cannot be equal to 5, but it could be 5.00001. Okay? So, anything greater than 5 forever. So we would say that x is greater than 5. Okay? Done. Let's say this one was a solid dot. That means it could equal -4, or anything less than -4. So we would show that by x is less than or equal to -4. See the difference? Okay. Now let's say this one was a solid dot, and this was a hollow dot, and it was all the values in between. Okay? So now x is going to be between 4 and 10, including 4, but not including 10. And when we want between values, there's an interval between here and here, we say this. 4 is less than or equal to x, or x is greater than or equal to 4. Okay? Which is less than 10. Notice there's no equal to here because it's a hollow dot. Okay, on this one, let's say I did both hollow. This would be -3 is less than x is less than +3. So this notation where x is between two numbers is how we show an interval or something between. Oh, this was in between. There we go. Okay, in this one, so we had a smudge here. This time we're going to do the reverse. We're going to graph that inequality. Okay, so this time I'm going to put down those two values, which are going to be the outermost values, -20 and -10. It's everything in between. But notice it's not equal to either of those values. Oh, I'm sorry, it's not equal to this one, so hollow dot. It could be equal to this one, solid dot. Okay, and everything in between. And we're done. Okay. suppose we were graphing inequalities in y. Well, if it was in y, we might have a vertical number line like this. Okay, so if this was 5, and we had a line like this, hollow line of 5, going up forever, this might say y is greater than 5, not equal to. If it was equal to, it would be a solid dot, and that would change that to greater than or equal to 5. Now let's put these two number lines together to form a graph. So this is my x-axis, my y-axis. So now if I have some value in here, from here to here, if I have a number scale here, I could give you how far left and right it's changed, as far as how far up and down it's changed. That change in x, or my horizontal change, is my domain, and this vertical change, or the change in y, will be my range. So first, let's look at this with our set or set builder notation. First of all, a set is a list of possibilities, including possible restrictions, written in curlicue brackets, those kinds of brackets. Note, set notation is the preferred way of writing the domain and range for a relation, especially in grade 10, 11, and 12. Now, it says here example 1. So here's a set of 4 ordered pairs. Remember, a relation can be written as ordered pairs and several other different ways. So the domain here is all the possible values, okay, of the x value, or the input, which is 2, 3, 4, and 5. So I write that down. Domain, set notation, 2, 3, 4, 5. Okay, that's the domain. The range, on the other hand, is all the y values, or the outputs, or the dependents. 5, 10, 15, 20. Okay, just that simple. Sometimes we have a table of values. Again, the domain is all the x values. So in this case, -2, -1, 0, 1, 2, done. The range is all the y values. And we like to list them in order from least to greatest. So I'm actually going to start here. 60, 70, 80, 90, and 100. Done. Okay, on this one, this time we have a line here. You can see by my scale here that this point here has coordinates -3, 1. And this point has coordinates 4, 3. Okay, so if I want to find the domain, it's how far from left to right it goes. From here to here. It goes from -3 all the way up to +4. Okay, that's an interval. So I'm going to go like this. I'm going to combine what I learned in Math 9 with what I just showed you here with the curlicue brackets. So, the domain, x such that, okay, that's what that symbol is, x such that, -3, it cannot be -3, notice the hollow dot. It's not a solid dot, it's hollow. So -3 is less than x, but it can be 4, because it's a solid dot, is less than or equal to 4. Comma, and because it is a continuous line, that includes -2.9 repeated, and -2.5, -2.1, all those values in between, even a value for pi here, 3.14 would be about there, okay? So it could be any real number in there. So there's where the restrictions apply. So we say x is in the set of real numbers, or an element of the real number set. Okay, done. Range, on the other hand, I'll change colors here. It's going from 1 all the way up to 3. It cannot be exactly 1 because it's a hollow dot. Okay? So I'd say y such that 1 is less than or equal to y, and it's going all the way up to 3. Is less than or equal to, because it's a solid dot, 3. And again, it's a continuous line, so it could be any fraction or decimal or anything else in there, even irrationals. So y is in the set of real numbers. Done again. Okay, let's try these ones real quick for practice. The domain, this spreads out forever. It's called a parabola. It's for a quadratic function. It's learned in grade 11. It spreads out forever. So the range is going to be all real numbers. Negative infinity to positive infinity. because there's no restrictions, we don't have to use the set notation. We can simply say x is in the set of real numbers. Okay, that's it. The domain, on the other hand, has a maximum point. It's right here. It's at 1, 2, 1, 2. The maximum value of that function is where y is 2. So I have to say y such that y is less than or equal to 2. And because it's a continuous line, it's just, okay, could be any fraction or decimal, y can be any real number as long as it's less than or equal to 2. Okay, let's try this one. This domain goes left and right forever because of these arrows. So I can just say that x, whoops, it's easy. See what I did wrong over here? I got these backwards. Low tech, low video, I'm not editing this. These are backwards. This is the domain, and this is the range. Domain is x, range is y. Sorry about that. Okay, domain x is in the set of real numbers because it goes negative infinity to positive infinity, left, right. And the range is going up and down forever, so y is an element of the real numbers as well. Okay, in this one, this is tricky. It goes left and right forever because of these arrows, but it's only the whole number and negative whole numbers. It's only the integers. So I could say here, the domain is x in the set of integers. Okay, so it doesn't include fractions and decimal. Same with the range. Y is in the set of integers. There we go. Okay, here's the last example. So my domain is going from -3 to +3. So, curly Q bracket, x such that -3 is less than or equal to x is less than or equal to +3. And x is in the set of reals because it's a continuous line. It has values for all these things here. And the domain, or sorry, the range, y is also from -3 to +3. Y such that -3 is less than or equal to y is less than or equal to +3, and y again can be any real number. Okay, the interval notation uses round and square brackets. In this particular case, interval by the way means from here to here. It could be time or distance or whatever. So from here to here, from -3 to +3, inclusive. So it's -3 to +3. It kind of looks like an ordered pair, but it's not because we specifically say the domain is this. And the range is also from -3 to +3. Whoops, I made another mistake. This should be a square bracket because it's inclusive. And the range is also -3 to +3. I use a round bracket if it's everything but. Let's go back to this one here for a second. Here, the domain was from -3 to +4, but it did not include -3. So I'd say the domain equals round bracket, -3, comma, +4, square bracket. This means it includes 4, and this means it starts at -3, doesn't include -3. And the range, on the other hand, is from -1 to +3. Again, doesn't include +1 to +3. It doesn't include +1. So 1, 2, 3. Does include 3 because of the huddled or the solid dot. Okay. Okay, that's it for now. Hope everything made sense. Bring questions to class and we'll talk next day. Bye for now.